Welcome to this explainer. Today, we're looking at the unexpected hero saving the future of wine with hemp. It's a high-stakes agricultural rescue mission and, honestly, a fascinating story that connects a surprising, often totally discarded industrial waste product directly to your favorite glass of premium wine. We're talking about leveraging biology to fight one of the absolutely biggest climate challenges of our time. So, what does a hemp rope factory actually have to do with the future of premium wine? I know on the surface, a factory processing industrial hemp for ropes and textiles seems literally worlds apart from a pristine, centuries-old vineyard in Europe. But the answer to this bizarre connection actually holds the key to surviving a massive, impending crisis in the agricultural world. To understand the solution, we first have to understand the scale of the problem. Let's look at Challenge 2026 Heat and Water. This is the looming macro threat terrifying vineyards across Europe right now. Picture this. By the year 2026, severe new water restrictions are hitting hard. Major wine-producing regions, we're talking France, Spain, Italy, they're forcing their agricultural sectors to cut water quotas by 20 to 30%. And this is happening right as brutal, prolonged 40 to 45 degrees Celsius heat waves are basically becoming the standard summer norm. Vineyards that can't adopt are facing crippling heavy fines, or even worse, the heartbreaking reality of having to rip out and reduce their actual vines. And that leads us to a terrifying biological phenomenon known as root baking. When the soil temperature crosses that 38 to 40 degrees Celsius mark, the vine doesn't just get hot, it panics. It enters the state of stress dormancy. It physically shuts down just to survive, which completely halts water absorption and stops the synthesis of sugars. If this happens during the ripening phase, the entire vintage is essentially ruined. So how do we stop this disaster from happening without pumping more water? Enter silica armor and the power of our unexpected hero. We're talking about hemp hurds, the discarded woody inner core of industrial hemp plants. Now, for decades, farmers have tried using straw or soft grasses as mulch to protect their soil. But traditional straw is just hollow, soft cellulose. It rots into a slimy mess almost immediately and flattens completely under the rain. Hemp hurd is an entirely different beast. Its cell walls form a rigid silica matrix containing 5 to 8% silicon dioxide. This micro-armor structure acts quite literally like microscopic bulletproof glass, giving the material this incredible, long-lasting integrity. And because of that rigid angular structure, when hemp hurd gets even slightly wet, the pieces mechanically interlock. They form a dense, breathable matting over the soil. This interlocking shield is so incredibly strong that it can effortlessly withstand 80-kilometer-per-hour summer storm winds without blowing away. Try doing that with traditional straw. It scatters at half that wind speed, leaving the delicate soil entirely exposed to the elements. Which brings us to our next concept, the mulch's hydrodynamic paradox. Let's see how this provides incredible water control at the absolute microscopic level. Here's the really cool part. Hemp hurd contains internal microchannels that are insanely tiny, just 10 to 50 micrometers wide. When rain falls or irrigation runs, these channels allow the herd to instantly absorb 4 to 5 times its weight in water, funneling it straight down to the soil. But wait, it acts as a two-way valve. The irregular shape of the herd completely severs the soil's upward capillary action. It lets water drain down, but completely blocks the sun from pulling that moisture back up and evaporating it into the air. It's brilliant. It's actually so efficient that it acts as a sponge for ambient moisture. Every morning, this hemp layer becomes a morning dew trap, capturing 2 to 4 millimeters of free atmospheric moisture daily. Instead of letting that dew just burn off in the first 30 minutes of morning sun, the hemp traps it and slowly releases it down to the vines over several hours. It's literally capturing free water from the air. Let's zoom back out to the vineyard level for thermal shield for roots and see this physics in action. Just look at the difference between these environments. Bare soil suffers massive, super stressful 28-degree daily temperature swings. It bakes at 42 degrees during the day, then plummets to 14 degrees at night. That is exhausting for a plant. But a hemp mulch row, it creates a beautifully stabilized, cool environment for the roots, narrowing that daily swing down to just 18 degrees and keeping those noon temperatures at a much more comfortable 36. And you know what's crazy? You only need a simple 4-inch layer of material to achieve this. Spreading just 4 inches of hemp hurd under the vines drops the punishing noon soil temperature by a massive 6 degrees Celsius. Remember our definition of root baking earlier? Yeah, this simple 4-inch application completely eliminates the threat of the roots shutting down from heat stress. Because the soil stays cool and that upward evaporation is completely blocked by our microscopic two-way valve, the water savings are honestly staggering. To put it in perspective, a single 10-hectare vineyard can save up to 700,000 liters of water in a single growing season. That's a game changer. Retaining all that moisture drops the required irrigation cycles for a typical vineyard from 15 times a season down to just 10. That saves thousands of euros in water and electricity for pumping, but most importantly, it keeps the vineyard perfectly legal and profitable under those strict 2026 government water quotas we discussed right at the start. And that leads us to the climax of our explainer, the taste of circular economy, a vision where this system fundamentally redefines agricultural economics. I absolutely love how elegant this closed-loop system is. You start at the farm growing industrial hemp. It goes to a factory where the outer fiber is extracted for textiles, and the inner hurd is just tossed aside as useless waste. Then, the vineyard buys this cheap local waste and applies it as a high-tech thermal and moisture shield. Finally, over 3 to 4 years, the hemp slowly breaks down, sequestering 1.5 to 2.5 tons of carbon and feeding the soil's microbiome. Literally, one industry's trash heals the earth for another. But hey, the ultimate proof is right there in the glass, right? Because the vines are entirely free from the panic of heat and water stress. They don't have to fight for basic survival. Instead, they pour all their energy straight into the fruit. Yields increase by 8 to 12%. The sugar content, or Brix, jumps by 1.0 to 1.5 points. And phenolic compounds leap by 10 to 15%, giving you deeper colors and richer tannins. In rigorous blind tastings, these wines are consistently scoring 6 to 8 Parker points higher than control groups. It's a profound shift in how we approach agriculture. As this quote perfectly captures, the best wine of the future won't come from fighting nature, but from borrowing its evolutionary advantages in a closed-loop ecosystem. So, the next time you take a sip of a beautifully complex, premium vintage, take a moment to consider the living soil it came from. And ask yourself, what other massive global crises could we easily solve just by looking a little closer at someone else's industrial waste? Thanks for joining me on this explainer, and I'll catch you next time.